Hi students, welcome back. So let us do the problems from the applications of friction. So in the previous class we have seen the concept of friction. There is nothing but ladder applications we have seen. Now I want to go for the applications of friction in case of the wedge. Okay. So wedge is one of the best application here. So what is the purpose of a wedge here? Wedge is an element, or it is a block which is having some trapezium shape, or it is having some irregular shape. Okay, and by using that block we can reduce the mechanical advantage. We can get the mechanical advantage here. We can reduce the effort. Okay, by using that block we can reduce the effect that we are applying to lift some other body. So wedge is an element which is used to raise or to lower the body which is having heavier weight. Okay, that means we can apply less amount of effort or less amount of force acting on the body there, right? Now I am going for the small problem for you. Just is a problem. So block A weighing 1000 newtons is to be raised by means of a 15 degrees wedge B weighing 500 newtons here. So the coefficient of friction for all the contact surface is given as 0.2. Okay. Now I am just drawing the figure for you. So this is a problem which is given. This is a block I am having. Right, so this is a block A here, this is a block B, right, and the weight of the block A I am saying here. So weight of the block A is given as 1000 newtons. Okay, so weight of the block B is equal to 500 newtons here. So these are the weights which are given for us, and the angle of wedge, see this is nothing but the angle of wedge here, this is called as the angle. So it is given as 15 degrees, and the coefficient of friction for all the contact surface is equal to 0.2. It is given. Reading once again because the letters are very small for me. So the weight of the block A 1000 newtons. Okay, and the weight of the block B is equal to 500 newtons. I can say the blocks here. So what is the purpose of this arrangement? And here a force is being applied here. Now we have to determine the force P which is necessary to provide the motion inside the block here. Now let us see here. We have two number of blocks which are resting one against each other. Okay, this block is resting against the vertical wall and the inclined surface of the block B, and this block is resting against the block A and the horizontal floor. Okay, the angle between these two surfaces is nothing but equal to 90, and the inclined surface is making an angle 15 degrees with the horizontal here, and this is called as the wedge. Okay, now what I want to do is, actually this is the object which is to be lifted or which is to be lowered. Okay, now I want to raise this block A in the upward direction here. Now the main objective of this arrangement is nothing but I want to lift this block A in the upward direction. I want to lift this block A in the upward direction here. So what we can do for that? I want to lift this block A in the upward direction. So for that we are applying this total arrangement. Okay, this is called as a wedge here, wedge WEDG. So it is called as a wedge here. Now on this wedge I am applying a force P in this direction. Okay, so whenever if you apply the force P in this direction here, this wedge will move towards left, and whenever this wedge move towards left here, this block will move in the upward direction. That is the phenomena here. Okay, in order to move this block or the weight A in the upward direction, so weight A in the upward direction, we are using this entire arrangement here. Now the thing is, to raise this block, what is the force P that we have to apply on this block here? That is the concept. Okay, so we can solve by using different methods here. The methods we have, but the best method I will suggest for you. So, but it is somewhat long, but it will be helpful for you a lot. Okay. Now first of all, we have to go for the numbering of the contact surfaces, because at every contact, see, we are in the concept of friction. Due to friction only this block will be lifting, right? So this is the best application of the friction here. See, this is the second application of the friction, the best application. And we can say that due to the application of the force P here, this block will move towards left and this block will move in the upward direction, I can say. That is the point here. Now, what is the amount of the force P we have to apply here? Okay. Now, I will go for the conclusion. The end of conclusion, I will go for one more points here. So, we have to determine the value of P. P is equal to how much, I can say. This is the value of P. How we can determine the value of P? So, this is the movement of the block upward. This is a moving block in the left direction, right direction. Right. Now, how we should start the problem? How we can determine the unknowns here? So, this is the wedge here. So, weight of the wedge is given to us. So, generally in some cases or in some problems, so in some problems, weight will not be given to you generally. So, weight will be generally nullified. So, weight will not be given to you. Okay. So, this is the force that is acting on the body here, which moves towards left, and this will be moving in the upward direction. So, how we should start the problem here? I will be starting the problem by taking this block here in the equilibrium. And let us see the contact surfaces. So, what are the number of contact surfaces I am having? I am taking these contact surfaces as the first contact surface. This is the contact surface with the floor. I am taking this one as the contact surface number 1, and I am taking this one as the contact surface number 2, and I am taking this one as the contact surface number 3. Okay. Contact surface number 3, I can say. Contact surface 3 it is. Okay. So, as I told, the number of contact surface, if you have 10 number of contact surface, you will be getting 10 number of inclined, you will be getting 10 number of reaction forces, you will be getting 10 number of frictional forces here. Now, it is the contact surface here. So, if you take this block, I am taking this block, the equilibrium of the block I am taking is equal to the inclined plane here. So, this is the force that is acting on the body here. Okay. And this is the normal reaction, nothing but the value N1. Okay. Direction of motion, whenever this P comes towards left, okay, this force, whenever this block move towards left, the direction of friction at all the contact surface will be acting in the opposite direction. Therefore, I am just providing, this is the direction of motion here. I am providing the direction of motion this way here. Okay. So, therefore, this becomes the direction of friction that is acting on the body, nothing but the value F1. And this becomes the normal reaction N2. And what about this one? Since the block is coming towards left, I can provide a friction force acting in the direction here. And one more important point is, the friction force always acts at the contact surfaces. It moves in this direction here. Now, depending upon this diagram. Now, this is the free body diagram for the block B. Block B it is. I am going for the free body diagram for the block A here. So, I am taking this diagram here. This is the block B. Right, you can see here. This is the block I am taking here. Okay. Now, what are the contact surface I am having? So, here, due to the application of the force in this direction, the block will move in the upward direction. So, here we have a contact. Therefore, you will be getting a normal reaction always perpendicular to the surface, nothing but the value N3. And this body will move in the upward direction. Therefore, frictional force will always acting in the downward direction, nothing but the value F3 here. Now, what about the normal reaction frictional force acting at this contact surface? And one more point is, this body will be having its own weight, and I am drawing this weight acting in the vertical downward direction, nothing but the weight of the block B I am writing. If weight is given, include the weight. If weight is not given, neglect the weight. No need to go for the concept of weight here. Okay. And what about this block here? So, direction here is very important. So, perpendicular to the surface, normal reaction will be always acting in the upward direction, acting perpendicular to the surface here. I can take this angle as which is equal to 90, definitely. Okay. What about direction of friction? Now, see here, this surface is in contact with this surface, we can say here. These two surfaces are in contact with each other. These two are in contact with each other. Okay. So, whenever these two bodies come together, all the forces should cancel with each other. Okay. So, since this surface is in contact with this surface here, the force that is acting in the surface is nothing but acting along up the inclined plane. So, we have to, along this surface, we have to get the force that is acting down the inclined plane, nothing but the value F2 is acting in downward direction here. Okay, that means if you bring these two bodies together, these forces should be equal and opposite with each other. Therefore, these two forces should cancel with each other here. That is the concept. Okay, therefore, I am just writing the equations of equilibrium, and the next thing is this body will be having its own weight that is acting in the vertical downward direction, and I am taking the weight. So this is the weight, this is the block WA here. Okay, so this is the block A, right? And this is the block B here. I am writing the equations of equilibrium. So I am going for sigma fx is equal to 0 and sigma fy is equal to 0. So before writing the equations of equilibrium, we have to go for the resolution of the forces here. So these three are horizontal and vertical inclined. But see, if you observe carefully, F2 is making some angle. This angle will be always equal to 15 degrees, right? You can see this angle here acting at this surface. Therefore, if you resolve this one, you will be getting two number of components here. So the first component will be equal to F2 into sine 15. Okay, and I can get the values F2 into cos 15 I can get. That is the value. So what about this normal reaction here? The angle, what is the angle made by N2? If you observe carefully, this N2 is making some angle 90 with the horizontal, right? Okay, 90 with the incline it is making. So how we can determine the angle made by N2? Okay, so how we can determine the angle made by surface here? Can you form a small triangle here? Yes, definitely. Since this angle is equal to 15, because this is equal to 15, this will be equal to 15, right? Okay, therefore if it is 90, definitely this angle will be equal to 75 degrees I can say. Therefore this N2 is making an angle of 75 degrees with the horizontal I can say here. If you resolve all the force acting in the direction, definitely this N2 is there, no? This N2 is making an angle of 75 degrees. And what about this value? F2 is making an angle of 15 degrees here. That is the concept. Now we can go for the resolution very simply. Now I am writing the forces acting on the body here. Okay, so horizontal force P is acting in negative direction, so minus P, and next thing is nothing but plus F1 I can say, minus P plus F1 I can say, and the next thing is what are the horizontal force we have? I can say this one as plus F2 into cos 15 degrees I can say. Next, we have any more forces? Yes, N2 is acting in the fourth quadrant, therefore I can say this one as plus N2 into cos 75 degrees. 75 degrees. So do we have any forces? No, is equal to 0 here. I am writing the equations of equilibrium for this body only. Okay, for this body only. I am writing the second equation of equilibrium, nothing but sigma Fy is equal to 0 here. Writing sigma Fy is equal to 0. So what about the force acting in the vertical y direction here? Acting in the y direction. Therefore I can say this one as plus N1, okay, minus W into B. We can solve the same problem by using other method also. It will reduce the steps I will try to do. Okay, so next I can say this one as F2 into sine 15 is the value. Sine 15 is the value. And the next thing is we have N2 also. N2 is coming in the fourth quadrant. Therefore I can say this one as minus N2 multiplied by the value of sine 75 degrees is equal to 0 is the value here, right? So therefore these are the equations. And if you observe carefully, how many number of unknowns we have? Here P is the unknown, F1, F2 are the unknown here. W value is known for us, okay? And we can write F1 is equal to mu into N1. So how many contacts we have? Total we have 3 number of contacts here. Therefore I can write this one as F1 is equal to mu into N1. And I can write the value of F2 is equal to mu into N2, and I can write this value as F3 is equal to mu into N3 I can write. So these are called as the equations of equilibrium of, these are the frictions here. So therefore I can write F1 is equal to mu N1, mu N2, and if you solve you can determine the values of N1 and N2 here. But by using these two equations we cannot solve the 3 unknowns. The unknowns are P, N1 and N2. Therefore we need some other equations to determine the values, okay? Now I am going for the equation of equilibrium for this body here. Actually, first of all, we have to write the equation for this body only. But we can write the direction. We can represent the direction of normal reaction. We can represent the direction of normal reaction by using this block only. Okay. So remember one point, actually we have to consider the block which is having less number of unknowns. But if you take this block directly in the examination, you cannot draw the frictional force directly. So how we can provide the frictional force directly? We can write the direction of frictional force by first considering this block in equilibrium here. By considering this block in equilibrium, then we can go for the equations of equilibrium. So depending upon this moment only, we can provide the direction of friction for this block. And then we can provide the frictional force direction here. And then we can go for the equilibrium of equations here. Now I am going to write the equations of equilibrium for this block here. So I am removing this one here. Would like to write the equations for this block. So this is the equation. So I am writing the first equation of equilibrium. So sigma fx equal to 0. So it is not possible to write here. I will write in the upward direction, in the top direction I want to write. So sigma fx equal to 0. I am writing the equations of equilibrium for this block. Okay. So what are the horizontal force acting here? N3 is horizontal and F2 is making some angle. You can observe here. If you extend this force F2, definitely this force F2 is making an angle of, what is the angle of friction? It is given 15 degrees. Not angle of friction is given as angle of wedge here. So F2 is making an angle of 15 degrees with the horizontal and it is moving towards the third quadrant. And what about N2? As I told, N2 is making an angle of 75 with the horizontal, right? Therefore, can I write this 75 with the horizontal here? Definitely I can place this angle which is equal to 75 with the horizontal. Okay. So you should be very careful regarding these angles. Okay. Now I am writing the equations of equilibrium. So N3 is passing towards positive x. So plus N3. And I can write this one as, minus F2. Minus F2 into cos 15 because it is moving along negative x direction. Okay. And next we have a force of plus N2. So not plus N2 is moving in the second quadrant. Therefore I can write this one as minus N2 multiplied by the value of cos 75 degrees, I can say. Okay. Is equal to 0. Do we have any forces acting in the horizontal direction? No. F2 and N2 are inclined here. Only N3 is horizontal. Therefore I can write this value is equal to 0. See, P is acting on this block. It is not acting on this block here. Therefore, I am writing the sigma fx is equal, y is equal to 0 here, the second equation. Is equal to 0. So, what are the forces acting in the vertical direction here? Therefore, I can write this one as minus F3. Minus F3 is the value. So, what about NA? W is acting in downward direction. So, what about the value of N2? N2 is acting in the second quadrant. Therefore, I can write this one as N2 multiplied by the value of sine 75 degrees. Okay. So, and I can write this one more value we have. So, what is the value of F2? Yes, F2 is making inclination with the 15 degrees horizontal here. It is making some inclination. It is moving in the third quadrant. Therefore, I can say this one as F2 multiplied by sine 15 is the value because it is moving in the horizontal vertical direction. Both the values will be 0. Negative. So fx and fy both the things will be negative here. Okay. So now these are the two equations. Now if you observe carefully, here we have N3, here we have F3. Therefore I can write F3 is equal to mu into N3. And here we have F2, here we have N2. Therefore I can write F2 is equal to mu into N2 here, right? So WA is known. Okay. So if you solve these two equations, you can determine the value of N2 comma N3, right? Determine these two values, N2 and N3. Now substitute the value of N2 in this equation. N2. Here you can write F2 is equal to mu into N2. Here I can write this value as is N2. WB is known. And you substitute the value of N2. And write F2 is equal to mu into N2. And if you substitute these values, okay, and if you solve these two equations, then you can determine the values of P and N1. Okay, you can determine the values of P comma N1. So this is the thing here. And the value of P after calculating the value, after doing all the calculations, the value of P I am writing here. The value of P is equal to 871 newtons. So now I want to say the very important conclusion. So what is this 871 newtons here? If you observe carefully, this is the force that is required. This 871 newtons is the force that is required to be applied on this block. Okay, to raise this block here. Okay, now listen. What is the weight of this block A? Is equal to how much it is given? This block weight is equal to 1000 newtons. Okay, so don't worry about this block B, because this block B is in the horizontal position. So he is lying on the ground level here. The entire weight of the block B will be acting in the vertical downward direction only. Okay, now this is the block 1000 newtons. The main motto of this arrangement is, I want to lift this 1000 newtons in the upward direction. I want to raise this one. To raise this one, we are using this block, and on this block we are applying this force here. Therefore, it is called as the wedge, or the intermediate member between the line of application of the force and the block which is to be lifted here. Okay. But what is the weight to be lifted here? 1000. And what is the force we are applying here? You can see here 871. Okay, that means we have reduced the effort, right? See, for example, this is a duster. For example, this duster is having a weight of some 10 newtons. 10 newtons. This duster is having a weight of 10 newtons. So it is resting on my hand here. Now what I am doing is, I am just lifting the duster. I am just raising the duster here. Okay. So whatever the effect that you are applying on the duster to raise the duster, okay, is always equal to weight of the duster. Okay. Whatever the force that we are applying here, it should be always greater than weight of the duster. Right. So in the same way, if you want to lift a weight of 1000 newtons, we have to apply the force which is always greater than 1000 newtons. Are you following? That means we have to apply more amount of force, but if you observe carefully, by using this wedge, we are applying only 871 newtons. Therefore, what is the amount we are reducing? So the minimum effort we are reducing is nothing but 1000 minus 871. Approximately we will be getting 129 newtons. So we are just saving that much amount of effort, nothing but 129 newtons. This is called as the mechanical advantage. Okay, and this advantage is gained by the wedge arrangement. This is the best application of the friction. Okay, nowadays we have screw jack and all those things to lift the entire weight of the automobile. Okay, but this is the first application. So before the commencement of friction, in the commencement of screw jack and all those things in traditional days, so people are using these type of arrangements only. Okay, right? So please note down. So we have to write the equations. Or else you can do one thing. You can represent all these values in terms of friction. See here, N3 and F3 is there, no? If you determine, see, N3 and F3 are perpendicular to each other here. You can observe carefully. N3 and F3 are perpendicular to each other, right? So these two can be reduced to a single force, which is called as resultant force. Okay, therefore, these two are reduced to a single force. Again, N2 and F2 are reduced to one more force. So single force. So you'll be getting two resultants here. Next. Here we have N1 and F1 are reduced to one resultant, and again N2 and F2 resultant are reduced to one resultant, right? So 1 you can get 2, 3. So therefore we have total 6 number of forces. 6 number of forces can be reduced to 3 number of resultant forces. Okay, so it becomes the application. Therefore we can reduce the number of forces. Some of the steps can be minimized here. You can do the problem in that way also. So please note down this one. So try to write all the equations here. So actually you may not get this much complex problems, but you should know all the concepts from the friction. That's why I'm telling all these things. I will do some problems from the GATE previous question papers, then you can get the awareness from the friction. So in what way he was asking, in what way he was giving on all the questions there. Okay, so let us go for one more problem in case of wedge here. So I'm having one more application of the friction, which is in the form of wedge only. Okay, I'm going to the next problem. Determine the force P required to start the wedge. Shown in the figure, the angle of friction is equal to 15 degrees. Okay, so I will try to complete this problem in 2 to 3 number of minutes. You can draw the figure, then you can understand clearly. So here we have this inclined surface here. In the previous case, we have the vertical and the horizontal surface, but here we have inclined and the horizontal surface. We have a wedge here actually. We have a wedge here. So against this wedge, I am having a small block. Okay, so try to increase the thickness here. What is there in that? Right, the blocks here. Here we are applying a force of 500 newtons. And here we are applying a force of 2000 newtons. 2000 newtons it is. And we are applying a force of P here in this way. So the angle of friction is 15 degrees it is given. And you can take that angle also. The angle of friction is equal to 15 degrees it is given. Degrees it is given. Okay, I am just producing the hatching here. No need to produce the hatching. These are the contact surface we have. So let us see how we can go for the contacts. I am taking this contact as surface number 1, contact surface number 2, contact surface number 3. I am going for. Try to understand the movement of the block, then we can go for the thing here, right? So how we can apply the direction of movement here. So we are applying the force on this direction here. So since we are applying the force in this direction, this block is coming down. So whenever this block comes down, this block will move towards right direction. And so we have to apply a force which is greater than 500, such that then only this block can move towards right. The main motto of this arrangement is, I want to move this block towards right. Okay, to move this block towards right here, I am applying the force in the downward direction. Okay, and on this block we have two number of weights here. So I think this is the weight of the block. So it is acting in the upward direction. Nothing to worry about that. So on this block we have two horizontal forces. So we have vertical and horizontal forces are there here on this block here. Now I want to move this block towards right direction. So I am applying a force P in this direction here. Okay. So even though if there is no force 500 here, this block will move towards right direction only. Therefore we have to apply more amount of force to overcome these number of loads acting on this block here. Okay, so 3 number of contact surface I am having. So first of all, try to draw the free body diagrams. Then I will write the equation directly. So let us take this angle of friction. So not angle of friction, the inclined angle is made is equal to some 15 degrees. Let us assume this one. So definitely the angle will be given to you, but I don't have the angle now. This angle will be given to you if it is given in the examination. Okay. Now what is the block I should consider here? As the first step. We have 2 number of blocks here. So I am going to consider this block. Okay. So I am just placing the block outside here. Right. So this is the force P that I am applying here. Next, what is the contact here? So this is the surface N3. Therefore I can always provide the normal reaction force always perpendicular to the surface, right? So this is the surface here. I am providing normal reaction force in this direction here. So next, what happens here? Frictional force. What about frictional force? Since this body is coming down, I can provide the frictional force acting in this direction, nothing but the value F3 I can write. F3. Okay. So we don't have any other angles for that, no, for contact surface, but we have a contact surface 2 here, right? So therefore, since the block is coming downward, I can provide the friction force something but acting in the direction nothing but the value F2, and this is your normal reaction nothing but the value N2 here. So these are the force acting on this body, and these are the wedge actually. So generally we will be applying the force on the wedge only, and if you observe carefully, wedge will be in the form of trapezium shape. Okay, and one more thing is, if the weight of the wedge is given, in the previous problem weight of the wedge is given for us, in this problem the weight of the wedge is not given for us. So if it is not given, neglect that one. If it is given, try to include the weight, that's all. Okay, don't worry about the weight. Okay, now this is the free body diagram. Now depending upon this diagram, I want to draw the free body diagram for this block here. I am taking this body in the equilibrium. Right? Okay, so this is the 2000 newtons I'm having, and this is the 500 newtons. So these are nothing but weights generally. So I think this 2000 is the weight of this block. So due to the downward motion of this block, generally what happens? This block will move towards right? So what is the direction of friction here? Therefore I can provide, this is the direction of motion in this way, and this is the direction of motion in this way here. It slides down because it is in contact with the inclined plane here. This is the direction of motion here, and this is the direction of motion here. It is acting in this direction. Therefore, I can say the frictional force will be always acting in the opposite direction. F1 it is, and this becomes a normal reaction nothing but N1. Okay, and what about this one? So this is the normal reaction nothing but the value N2, and this block is coming down. See here. So to this contact surface, this is a junction surface H. So this surface and this surface are together here. Okay. Now on this surface, what is the friction we are providing? Upward. So since this is surface is acting in downward direction, acting this junction here, try to provide the friction force acting in downward direction here. So on these two contact surfaces, the normal reaction friction force should be equal and opposite to each other. Okay, so N is acting towards the body, F2 is acting up the body, and F2 is acting down the body here. Okay, now for this body, write the equations of equilibrium. For this body, write the equation. No need to go for sigma m is equal to 0 here. So because to apply sigma m, we need the distances here. So there is no need of writing distances here, right? Therefore, I can write this value here. In this case, what is the problem? Equations I am writing. So I am writing the first equation here, which is equal to sigma fx is equal to 0. Fx is equal to 0 here. So what about the forces? N2 is acting in this direction. So minus N2 direction. What about friction here? Friction force is acting at an angle of 15 degrees with the horizontal. So if you resolve this friction force F3, I can get the components as minus F3 multiplied by cos 15 degrees. What about N3 here? If you extend this line, and if you extend this, then definitely you can form a right angle triangle here, right? Okay, I think you can see this right angle triangle here, which is formed by extending the lines here. Since this angle is equal to 90, this is 15. Therefore, this angle will be equal to 90 minus 75 will be equal to 15 degrees here, isn't it? So this is 15. This is 90, therefore this angle will be equal to 75 degrees here, and this N3 is making an angle of 75 degrees with the horizontal. Therefore I can say this one as plus N3 into cos 75 degrees. Plus N3 into cos 75 degrees is the value. Right? So do we have any more forces here? No. So there are sufficient forces. Yes. N2 is there. N3 and F2 are inclined. Okay, sufficient. Therefore I can write this value is equal to 0 here. Therefore, I am going for sigma Fy is equal to 0 here. The next equation of equilibrium. Fy is equal to 0 I am writing here. So, P is acting in the downward direction. Therefore, I can write this one as minus P. Next, F2 is also acting in the vertical upward direction. So, plus F2 I can write. So, what about here N3? N3 is making an angle of this one here. So, if you resolve this one, N3 sin 75 you can get. And I can write this one as N3 into cos 75 degrees I can say. Okay. Therefore, I can write this value as 75 degrees I can say. Okay, so next force I can represent this F3 here. So F3 is making an angle of 50 degrees with the horizontal. So vertical component will be equal to this making the horizontal. So N3 into sine. So what is the angle made by N3? Sine 75 degrees. So N3 is already completed. I am sorry. I am going for the force F3 here. The value will be equal to F3 multiplied by what is the angle here? It is equal to y direction. If I can write it as F3 into sine 15. Let us see any more forces are there here acting on the body. So P is the vertical force, F2 is the vertical force, N3 is the vertical force, F3 is the vertical force. We'll be getting only 4 number of components here. So write degrees and equate it to 0. Now, if you solve this equation, you cannot determine the value of P because we have 3 unknowns here. So N2, here I can write this value as F3 here. Again I am writing, I can write this value as F1 is equal to mu into N1. So F2 is equal to mu into N2 I can have, and F3 is equal to mu into N3 I can have. These are called as the equations for the frictions here. Okay, so substitute the value of mu is equal to N3, F3 is equal to mu into N3, N3 as it is, F2 is equal to mu into N2, and this is called as F3 is equal to mu into N3. Write it out. Okay, so keep two equations aside. Now I am writing the equations of equilibrium for this block. It is a simple plane block here. We don't have the inclined here. Simply I can write. So therefore I am writing the equations of equilibrium for this block. For this block I am writing the equations of equilibrium here, right? We can see here what are the horizontal forces. So N2 is horizontal. I am writing plus N2 minus 500, and the next thing is minus F1. Okay, so we don't have any force. I am writing it equal to 0. So what about sigma Fy is equal to 0 here? So the equations will be equal to minus 2000. Okay, so vertical force plus N1 acting vertical upward direction. So minus F2 I can write. That's all. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is equal to 0. Equations. Now I can write this value F2 is equal to mu into N2. And I can write F1 is equal to mu into N1. Now solve these two equations and you can determine the value of, you can determine the values of N1 and N2. You can determine the values of N1 and N2, right? From these two equations. Okay. After determining the values of N1 and N2, substitute in these equations. So no need to substitute the value of N1. Actually, no need to calculate the value of N1. We need the value of N2 only. Now substitute the value of N2 in this equation. Substitute the value of N2 in this equation. Okay, in those two equations. Then we'll be getting the equations in terms of P and N3. You will be getting the equations in terms of P and N3. Right? Now solve these two equations. You can determine the values of P and N3 here. Okay. So after substitution of all the values, the value of P, after doing all the calculations, the value of P is equal to 944 newtons. Value of P, I am writing the final value here, which is equal to 944 newtons is the value. Okay. Now you can observe that force. First of all, note down, I will explain once again. Please note down. Okay. Please note down. This is the final value. So you can get this value of P by solving these two equations only. Okay, please note down. So this is the last problem from applications of friction. So we have one more simple bit I am having. I will solve that one from friction, and after that I will go into the previous question papers to determine the concept from the concept of friction I will going. So this is the last problem from the wedge. Okay, so you should be able to solve any type of the wedge that is given to the examination. So first of all, try to solve a problem. Try to solve the block which is having less number of unknowns, but we can get the direction of friction at the junction surface, at the contact surface, by just considering the block upon which we are applying the force. Okay, now what is the conclusion is, I want to say a small conclusion here. So this is the block which is to be moved towards right. This block is to be moved towards right here. On this block these two forces are acting here, right? Okay, and on this block we are applying a force P that is acting in a downward direction. Okay, now what is the force we are applying? Is 944 is the value here. So what is the force we are, what is the weight, what is the block, what is the force that is acting on the 2000 and it is 500 here. So you can see this 944, even it is less than 2000. That means with less effort we are moving this block here. Okay, that is the important point we can say, and we can apply this, we can use this one, you can, that means we can move the heavier weight by applying less amount of effort by using this arrangement. Okay, and this is called as wedge arrangement here. This is called as wedge here. Therefore we can get more mechanic, we can reduce the mechanical effort and we can get the mechanical advantage by using this arrangement here. That is the purpose, that is the main purpose of this arrangement. Okay, let's note down. Right. Now see here, I am going for the next problem, very important problem. Right. What is the, Josh asking problem, what is the highest position for the horizontal force P that would be applied to permit it to just move the block without tipping, sorry. So tipping is different from slipping. I will just explain the concept of slipping and tipping. What is the highest position of the horizontal force P that would permit it to just move the block, moving is nothing but sliding, we can say. Okay, to move the block without tipping. I will just draw the figure for you. This is the block. So on this block, this is the height of the block here, and this is the base of the block here, and it is given the weight of the block is equal to m into g. Now what I am doing is, what we have to do is, actually we have to move this block with a force of horizontal P. The horizontal force P, I am going to move this block here. Okay, now see here. Now this is the block, it's having some base B and height h here. On this block, I have to apply a force P in order to move this block without tipping. Tipping in the sense, rolling about a point, rotation about a point here. For example, see, I am removing this force here. For example, let us see. If you apply the force P at the topmost position, so maximum the topmost position if you apply, so generally what happens here, Due to the application of the force here, there may be chance of tipping of this entire block here, right? This is the position of the block. Due to the application of the P at this position, the entire block may rotate about a point P here. So it should not happen. Okay. Now, what is the force P? Not the force P. What is the height at which we have to apply the force here? For example, if you place the force at this position, for example, definitely there is no chance of tipping. Definitely there will be a chance of sliding of this block. Sliding in the sense just having the entire surface, entire base of the rectangular block with the horizontal surface, it just slides towards left here. Okay, such that this base of the block will be having entire contact with the surface or the ground level. Now, what is the force that we have to apply on this block such that this block cannot roll, it cannot tip here. Okay, if you go on increase the position of the force P here, then the block will be tipping. Now, what I want to do is, what is the height at which? What is the height at which? I will draw the figure once again. What is the height at which the block will not tip over? Maximum height. P. Height H. Okay. Let us assume that at this position I am applying a force P at a distance of some x or y from the horizontal. I am applying the force P at a distance of x from the ground level such that at this position the block will tip over. Okay, just assume you can understand clearly. Actually, we cannot find the distance directly. We cannot find that. So what will be assuming is let P be the distance, or let X be the distance at which this block starts tipping. Okay, and by taking the condition of tipping, I will just apply the equations of equilibrium. Okay, now see here. This is the force that is acting in this direction. So whenever the body tips, generally what happens here? So whenever this body tips here, only one point will be in contact here. Let us assume this is the point of contact A and this is a point of contact B here. So whenever it lifts here, this will be the point of contact A here, right? So since it is having the point of contact here, this becomes a normal reaction in A. And what is direction here? See this block, this force, the direction of sliding, there may be a chance of direction of sliding here. Force P is acting in this direction. Friction force B always acting in the opposite direction. Remember the value FA, it is acting in this direction here. Opposite direction of motion of friction force will be always acting, right? Okay. Any more force we have? No. This is nothing but height H we have. Now all those things I can say. Okay. So this is the direction. This is the diagram thing here. This total height is equal to H I can say. This total height is nothing but B I can say, right? Now, how we can determine the value of here? I am taking this value is equal to X here. X I can say, or you can study the figure from this diagram also. You can directly write. I am removing this hatching surface and just providing the normal reaction here, that it becomes the point here. Since only one corner is in rest with the ground, therefore I can say this one is equal to NA. Okay, and this is the direction of friction, nothing but the value FA I can say. NA. Okay, now how we can solve the problem here? If you take the moment center as A, then NA and FA will become 0. Okay, now we have to calculate the value of X here. That means since we have to calculate the value of X, definitely we have to take we have to consider the equation of moment. So unless you consider the equation of moment, you cannot calculate the value of X here. So let us see the equations here. So if you write sigma f x is equal to 0 and fi is equal to 0, one more thing is we have the weight of the block which is equal to W. So weight of the block is always equal to m multiplied by the g, nothing but m into g gives the value of the block. W is equal to m into g I am having. Okay, I am writing the equation, the first equation I am writing sigma fx equal to 0 I am writing here. So fa is acting in this direction towards right and p is acting is equal to 0. I am writing sigma fy is equal to 0 here. Force acting in the vertical direction. So Na is acting in the vertical upward direction. Okay, so weight is acting in the vertical downward direction. So we don't have any force. I am writing this value is equal to 0 here, right? Now in which direction, at which point we have to take the moment center. I am taking sigma MA is equal to 0. You can take sigma MB is equal to 0 also, because we need the value of x here. But if you take the moment center as A, NA and FA will become 0. The moment of NA and FA will be equal to 0 here. Therefore, what about this force F here? This is the moment center. This is your moment center here. Okay. The P is acting in this direction. I am transmitting the force in this direction here. So P will try to rotate the body in this direction here. So P into, I can see this value as x here, right? So trying to rotate the entire body in the anti-clockwise direction, if I can write this one as P multiplied by the value of x is the value. There is a moment of the force P about the point A. Next, what about this weight here? Weight is acting in this direction. Here. Distance from the point A to weight is always equal to B divided by 2, because this total value is equal to base B. Therefore, this value is equal to B. W is trying to turn in the clockwise direction. So therefore, I can say this one as W multiplied by the B by 2 is equal to 0. One more important point. For example, if there is no friction here at the contact surface, then the body cannot rest here. The body definitely, due to the application of the force, the body will immediately fall down. There is no chance of tipping also. Okay. So therefore, I can write this value. I need the value of x here. Let us see here. I can write W into B divided by 2 is equal to P into x I can write. And I can write the value of x is always equal to, so W into B divided by 2 into P. But I am writing the value in terms of some other relations here. So I need the value of x here. So how we can determine the value of x? So see here, I can write this value as NA is equal to W. This is the relation here. NA is equal to W. And I can write this value as FA is equal to P. So P is equal to FA I can write. So this relation came from this equation here, and this relation came from this equation. Therefore, I can write this value as P is always equal to mu into NA, and I can write this value as P is equal to mu into W I can say. Okay. Now I am substituting the value here. So x is equal to, what is the value of W here? I can write the value of W is equal to NA. Okay. So write the value of W here. W into B divided by 2 multiply, what is the value of P here? P is how much I can say? Mu into W is the P. Therefore, if you cancel these two, you will be getting the value x is always equal to B by 2 mu you can get. This is a relation for the value of x. Therefore, x is equal to B divided by 2 mu. This is a relation here. X is equal to B by 2 mu. And this is the distance. Very important point I am going to say. This is the distance at which the block tip over. The block tips. Okay. For example, if you substitute the value of B, you'll be having some value. For example, let's assume that B is equal to some 10 meters. 10 centimeters I am saying. So mu is equal to some 0.2. Okay. Substitute the value of B and mu. Then you can get some value of x. Okay. Now at this distance, for example, x is equal to some 6 centimeters I am saying, for 6 centimeters. Therefore, if you apply the force P at a distance of 6 centimeters, the block will tip over. Then we can say a small conclusion that we should not apply the force P. We should apply the force P below 6 meters or 6 centimeters height. We should apply the force P below 6 centimeters height. Then the block will not tip over. Then the block will only slide. That is a very, very important point. Therefore, we have to apply the force P. Okay. So for tipping, for only sliding, for only sliding, we have to apply the force P such that the distance should be always less than x. Okay. Force should be applied always below x. Right? There is a thing here. Okay. So if you apply the force P above the distance x here, then the body tip over. If you apply the force P below the distance x here, then the body just only slides in this way. Sliding is nothing but the entire base of the rectangle will be in contact with the horizontal flow. That is the thing here. So please note on this one. Please note on that one. Okay, now let us go for some previous problems from previous question paper. So before entering into the concept of previous question papers, I want to discuss regarding the wheel friction, rolling friction I want to go for. Now actually till now what we have seen is, if any block is just sliding over the inclined plane or the sliding over the horizontal plane, we have seen the direction of friction and all those things. Now if any body is rolling, having some contact with the surface, okay, if any body is rolling which is applied with the horizontal force acting on it, if any body is rolling applied with the torque on it, okay, then how we can apply the direction of friction, just what I want to say. Please note on this one. Right, now see here, I'm just taking this concept as the rolling friction. Right, now simply I'm saying the block, I'm taking one more body which is in the wheel, in the form of a wheel here. Right, now see, I'm taking two number of objects, actually two number of wheels I'm saying. For example, I'm taking a wheel here. Now what I want to do is, I want to roll this wheel towards right side without sliding. I want to just roll this one without sliding. So we have actually different things we have discussed in detail. Well, so in the problems I will discuss in detail. I want to roll this wheel, okay, with respect to the right direction, towards the right direction I want to move. So for this block, I want to roll this body also towards right side. So for that we have two types of things here. We can move this body by just applying a force P in this direction here. You can apply the inclined force, you can apply the horizontal force, whatever the thing may be. Then what generally will be happening? This body will be moving in this direction here. Due to the application of the force P, this body rolls and it moves in this way here. Now what I want to do is, this is the force P that is applied externally here. Just by applying some hand, if you apply some force on the wheel in this way, if you push this one, then the wheel will roll immediately. Now what I am doing is, I want to rotate this wheel with the help of a torque. the help of a torque I am rotating here. So if you rotate the wheel with the help of a torque, then also the body will move in the direction here. Okay, this is the direction of motion, and this is called as direction of motion here, right? This is the point. Okay, this is a torque I am applying at its center. Due to this torque, it is moving towards right, and due to the applied force, it is moving towards right here. So now, if you draw the free body diagrams, what becomes the direction of friction? Okay, now I am going to draw I want to go and draw the free body diagram for this one. So it is the free body diagram I am going to draw. This is the horizontal floor. Okay, now it is the force we are applying on the body here, and this is the direction of motion here. So till now we have seen that the direction of motion, actually we have seen the direction of motion only for sliding bodies. Now there is nothing but direction of motion for rolling bodies here. Okay, now since it is having the point of contact, definitely be getting the normal reaction NA. Since the body is moving towards right, you can get the friction force acting in the downward opposite direction here. And there the weight of the body will be always acting in the vertical downward value mg, I can say. This is the free body diagram for this one. Free body diagram for this one, I can say, is nothing but the value mg. But if you take this body here in the equilibrium, therefore, see, this is the free body diagram for this body I am drawing. Now I am going to draw the free body diagram for this body here. Okay, so I am taking the horizontal surface here. Now this is the direction of motion, I can say. Okay, and this is a torque. Due to the application of this torque, so generally what happens? The first thing is normal reaction will be always acting in vertical downward direction. So weight will be always acting at its center. Then the center of gravity we have to say, because it is a solid body. Torque I am saying here. So what is the direction of friction I am saying is very important point, direction of friction. See here. If you apply the torque, this body starts moving towards right side. Then the direction of friction will be always acting in the direction of motion here. That is the main important thing. Okay, that means we are just applying the turning moment at the center of the wheel. So this is the best example for the automobile wheels here. So how the wheel of the automobile will be generally rotating. Okay, so we cannot push the vehicle. So we can push the vehicle. Even though if you push the vehicle, the direction of friction will be acting in this way here. If you push the vehicle in this way. But if you move the vehicle with the help of your accelerator, then what will be generally giving? So the power will be coming from the engine to generate, coming to the differential, and will be given into the couplings here, right? So the coupling wheel. So the wheels will be rotating here in this way. In this way we are applying the torque in the body here. If you are applying the torque at the center of the wheel or the center of the vehicle, then the frictional force will be always acting in the direction of the motion. Okay, if the frictional force is not acting in the direction of motion, then the body will just roll, but it will not slide. It will not just move here. Okay, we should have a sufficient amount of friction. I will go for a simple example for you. For example, let us assume that this surface doesn't have any friction. Okay, let us this entire area is covered with the help of sand. I am taking that this total surface is having some sand here. Sand. Okay, so if it is in the sand, in the sense there is no friction that is getting from the surface onto the body here. If you have only the sand here, due to the application of the torque, generally what happens, the body will just roll, okay, and the entire sand will be lifted in this direction. So to and fro direction, the front and backward direction, sand will be lifting, but the body cannot move in the forward direction. It will just roll in the sand, that's all. But you have some sufficient amount of friction here, then definitely the body will roll, at the same time the body will slide also. But here if you observe carefully here, if you have certain amount of force, even though if you have some sand here, even though there is no friction here, definitely the body will move in this direction. Will slide. That is the best example I can say. Okay? Remember one point, if you are applying a translatory force, if you are applying a linear force acting on the body, definitely the body will be having the friction. The friction will be always acting in the opposite direction of the motion here. If a body is rotated with the help of torque, which is acting at its center, then definitely friction force will be always acting in the direction of motion here. Very important. So examination will be telling the wheel of an automobile is being rotated with the help of some torque here. So what is the amount of friction force we are getting? Then you can get. And the torque that is required to overcome the friction is always equal to force multiplied by the radius of the wheel. You can say distance from the torque to the center is always equal to radius r, right? So what is the twisting moment? The twisting moment is always equal, torque is always equal to force that is multiplied by the radius. It gives the value of the torque here. Okay. So how we can determine the friction here? So friction can be always determined by two steps here. See, we can write the value. Friction is always equal. I am taking, for example, this is a contact surface here, a frictional force here. So I can write FA is always equal to mu into NA, I can say here. Okay. So what is the value of NA? I can write FA is equal to mu into NA is nothing but W. And how we can write? So weight of the body will be always acting in the vertical downward direction, nothing but the value WA, I can say. Not WA is nothing but W. Okay. So weight of the entire block I am saying, this one as WA I am writing here, acting in the vertical downward direction. W acting downward direction, normal direction acting in upward direction here. So I can say NA is always equal to W. Therefore, this is the value here. And I can write the value is always equal to some FA into R. So T is always equal to, what is the value of FA is nothing but mu into W into R. This is the torque required. This is the torque required to rotate the wheel. Okay. Which is having some friction at the contact surface here. This is a very important step. Okay. And this is the concept regarding the friction that is present between the rolling bodies and the horizontal surface here. Okay. So please note down this one. Please note down that one. Okay. So I am going to solve some previous question papers from the GATE examination for the concept of friction. Okay. Yeah. Now see here. I am going for the problem in case of the friction. First problem. Yes, see here. A 1 kg block is resting on the surface with the coefficient of friction is equal to 0.1. A force of 0.8 Newton is applied to the block as shown in the figure. The frictional force is, let us see. Okay, now see here. Is equal to, I am drawing the figure for a very simple bit it is. So, but it involves some concept here. Right. So, this is having a mass of 1 kg. On this mass of 1 kg, I am applying a force of 0.8 newtons. Okay. So, weight is equal to 0.1 and the coefficient of friction at the contact surface mu is equal to 0.1 it is given. Okay, so read the question carefully. A block of 1 kg is resting on the surface with the coefficient of friction is equal to 0.1. a force of 0.8 newtons is applied to the block. We are applying this force on this block here. The frictional force is, now if you apply this much amount of force, what is the frictional force he was asking? Just think of it. Now see here, this problem is given for 2 marks in the previous question paper. In the previous question paper it is given. So how we can determine this value? So how we can determine the value of frictional force? So see here, I have given the introduction for you. Okay. Whatever the actional force we are applying, see for example if you draw the free body diagram on this block. Okay. Now generally what happens, whatever the weight of the block the body is having, the same amount of normal reaction force will be acting on it. So more the value of weight, more the value of normal reaction force we can get here. So W will be always equal to N. Okay. So due to the application of W only, the N will be developed here. Now what I am doing is, I am applying a force of 0.8 newtons on this block. Now due to the application of the force, the body may move. Okay. Okay. Now what he was saying is, what is the amount of friction? And what he was saying is, very important point is, the block, a 1 kg block is resting on the surface with coefficient of friction 0.1, a force of 0.8 applied on the block. The frictional force is, as I told, this is the actional force we are applying on the body here. Due to the application of this force, the frictional force is developed here. Okay. And whatever the frictional force that is developed will be always equal to the applied force. I am taking this force as an applied force here. Okay. So if you apply more amount of, see, this is the concept of limiting friction here. As much amount of actional force you apply on the body, that much amount of frictional force will be developed here. Okay. Therefore, we can definitely say that F is always equal to P, and I can say this one as F is always equal to 0.8 newtons. This is the problem. It is given for 2 marks. So generally what we will be doing is, in the examination we will be calculating in this way. So P is, it is acting in the opposite direction, right? So P is always equal to F, that is always equal to mu into N. So what is the value of mu is nothing but 0.1, and what is the value of N is nothing but weight. So weight is always equal to 1 into 9.81. So we will be writing in this way, and this value will be equal to 0.981 newtons is the value of the friction. You will be calculating this, but this becomes wrong, and this value is also given. This value is also given as C bit. Okay, but this is the right option. 0.8 newtons is the right option. Okay, that is the concept of friction here. Whatever the amount of force we are applying on the body, the same amount of force will be developed in the form of friction. So if you apply this one, then it will be entirely different here. So this is the right one. Okay, so keep this point in your mind. Therefore, the right option is for the 1.41, it is B option, is 0.8 newtons is the right answer. There is a question, please note down that one. Okay, so I am going for the next problem. I'm going for the next problem here. Right. The problem is, a block weighing 981 newtons is resting on a horizontal surface. The coefficient of friction between the block and the horizontal surface is mu is equal to 0.2. A vertical cable attached to the block provides partial support as shown in the figure. A man can pull horizontally with a force of 100 newtons. So what will be the tension in the cable if the man is just able to move the block towards right? I will draw the figure, and this problem is given in 2009 for 1 mark. 2009 it is given. This is the block here. So this is connected with the help of a tension string here, and it is the center of gravity G he was giving, and this is given as 100 newtons we are applying here. The coefficient of friction of the contact surface is equal to 0.2, it is given. Okay, I will read the question once again. The weight of the block is given as 981 newtons. Is given as 981 newtons here. So this is the block here resting on this surface. The weight of the block is equal to 981 newtons. The coefficient of friction between the block and the horizontal surface. This is the block, this is the horizontal surface here. The friction between these two is equal to 0.2. The vertical cable, a vertical cable is attached to the block. This is a block, provides partial support as shown in the figure. A man can pull horizontally with a force of 100 newtons. A man is applying a force of 100 newtons here. So what will be the tension in the cable if the man is just able to move the block towards right? Okay. Now see here, this is the block. So on this, the weight of the block is given as 981 newtons. On this block, we are applying a force of 100 newtons here. Okay. And this block is connected vertically with the help of some string. Okay. So therefore what we can say, the force in the string will be always equal to tension force, right? Now what is the, I want to determine what is the value of, what will be the tension in the cable if the man is just able to move the block towards right? What is the tension T? I want to calculate. Okay. Simply draw the free body diagram of this block here. You can understand clearly, right? I am drawing the free body diagram of this block here. So this is the force that is acting on the body, and this is the tension force. So since it is in contact with the floor, it's nothing but weight, and you will be getting a normal reaction force acting in the upward direction. And since the block is moving towards right, therefore, and it is having impending, it is not moving actually, it is having impending motion towards right due to the application of this 100 newtons force. Therefore I can say this one as the value of F here. Okay. Now what we can write, I can say this one as, see here, if you write sigma fx equal to 0, fx is equal to 0, I can write 100 minus f is equal to 0 here. And this is the equation which came from sigma fx is equal to 0 here, right? This is the balancing equation. So therefore I can write this value as sigma fy is equal to 0, second equation I am writing. So tension force is acting in upward direction, so plus T, normal force is acting in upward direction plus N, minus W is equal to 0 I can say. Okay. So now we need the value of T. So T is always equal to W minus N, which is equal, what is the value of W? I can, W is always equal to 891 minus, so what is the value of normal reaction here? So you can determine the value of normal reaction from this equation. So I can write F is always equal to 100 here, equal to 100. So F is nothing but mu into N is equal to 100. So what is the value of mu is equal to how much? 0.2. Therefore 0.2 into N will be equal to 100. Then you can determine the value of N from this relation and substitute the value of N in this equation here. Then you can determine the value of T. Okay. So please note on that one. $100 is equal to F. Okay. So you can get the value of N is equal to 500. I am writing here. You get the value of N is equal to 500 newtons. Five newtons is the value. And after substituting all the values, we'll be getting T plus R minus W is equal to 0. Therefore, the final value is equal to 481 newtons is the value here. So we have done more than sufficient. All these are simple problems in the GATE examination, right? So try to understand the concept. Then you will be able to determine all the problems, all the values from the question papers, the examination also, right? So this is equal to T is equal to 481 newtons, and this is given for 1 mark in the 2009 question paper, GATE examination 2009. It is given for 1 mark. Please note down. Okay. Next we have to go for theoretical bit I am having. Yes. So this is the application of the belt friction here. Application of the belt friction, that means you will be having some friction that is present between the belt and the thing, belt and the roller, or the body about which it is circumference or the supported. Right? Now see here, there is a problem. The ratio of tension in the ratio of the tension on the tight side to that of slack side in case of flat belt drive is. Okay. Now see here, generally this is the roller here. About the roller, the belt will be always rotating. This is the position of the roller, always rotating with the help of torque here. Okay. This entire belt. Okay. So this belt will be subjected to two tensions here. For example, I am taking this one as tension T1 and I am taking this one as tension T2 here. And if you observe carefully, this will be subjected to more tension comparatively. Compared to this one, this will be subjected to more tension. And we have a relationship which is called as T1 by T2. T1 by T2 is always equal to e power mu theta is the value here. So this is a very important relation here. So sometimes he will not give the problem, he may give the theoretical bit here. So T1 by T2 is equal to e power mu theta is the value here, right? So you are telling the ratio of tension on the tight side to the slack side in a flat belt drive is, he was given the options in this way. The first option is proportional to the product of the coefficient of friction and the lap angle. So what is it called as lap angle here? Theta. It is the angle by which the total belt is in contact with the surface. Okay. Now you can observe here, this is, for example, this becomes the contact angle here. So this is called as the total contact angle, right? So along this total surface, the belt is covered here, right? Therefore, I can say this total angle is equal to lap angle generally, and I can say this one angle as theta here. Okay. And proportional to the product of the coefficient, of friction lap angle. Second one, an exponential function of the product of the coefficient of friction lap angle. Third one, proportional to lap angle. And next thing is proportional to coefficient of friction. We don't have any proportionality here. The correct option is the ratio of tension on the right side, the ratio of tension on the tight side to the top slack side in a flat belt drive is an exponential function of product of the coefficient of friction, the lap angle. You can see here, T1 by T2 is always equal. T1 stands for tension in the tight side, T2 stands for tension in the slack side. Slack is nothing but somewhat loose. Is equal to exponential power product of, what is the product we can say? It is the product of the coefficient of friction multiplied by the lap angle. That's all. So it is the second option, and this is given for 1 mark in the 2000 question paper. 2000 it is given for 1 mark. Okay. Okay. So please note down this one. This is a very important relation here. Okay. I'm going for the next question for the previous question paper. What he was saying is a steel wheel of 600 mm diameter on a horizontal steel rail. A steel wheel of 600 mm diameter on a horizontal steel rail. It carries a load of 500 newtons. The coefficient of rolling resistance is equal to 0.3. Just now we have seen the rolling friction. The force in Newton necessary to roll the wheel along the rail is. The force in Newton that is necessary to roll the wheel along the rail is. So there is a question 1.14 it is given. Let me see the question here. So it is given in the 2000 paper for 1 mark it is given. Okay. So let me draw the diagram, then we can get everything. Okay, diagram is not given for us. If you observe carefully, see, it is the wheel here, wheel of a locomotive, and it is resting on the horizontal floor. So nothing but, you see, for example, the wheel of a train, for example, the wheel of a bogie, a compartment of a train that is at rest. It will stand on the rail here, right? So I am taking that example here. Okay, the wheel of the train, one of the wheel of the train is resting on the rail here. This is the entire rail here. I am taking this one as the rail. I am taking this cross section rail here, right? And this is the rail section I am taking, and I will give the dimensions for you. This wheel is having a diameter which is equal to 600 mm. Okay, and it carries a load. It carries a load of, for example, I am taking this P is equal to 500 newtons is the load. Okay, the coefficient of rolling friction, I can say this coefficient of rolling friction is equal to 0.3 newtons. Diameter is given. Now what I want to do is the force in the Newton necessary to roll the wheel along the rail. Okay, so what is the force that is required to roll this one? I want to roll this one such that it moves in the right direction, and the weight that is acting, the load that is acting on this wheel is equal to, so 500 it is given. So how we can solve the problem? So what he was asking is, what is the force in Newton necessary to roll the wheel against the rail here? Okay, one more important point is, I am just telling once again, whatever the force that is required to move the wheel, the same amount of force will be developed in the form of the friction here. Okay, therefore whatever the friction force that is acting at this surface, we have to overcome that friction, and then the body starts rolling in this way here. Okay, therefore, for example, if it is the direction of friction that is acting here, and this is the force that is required here, nothing but P, in order to move this body here, therefore definitely I can say that P is always equal to F. Okay, now what is the value of F here? F is always equal, I can say this one as mu into N. Okay, and this weight, we don't have any weight, actual weight is not given for us. This actually weight always acts in vertical downward direction, will be having the normal reaction here, and I can write this value always, N is always equal to 500 newtons. Therefore F will be equal to mu is equal to how much? 0.3 multiplied by N is equal to how much? So into 500. Therefore we will be getting the value as 150 newtons is the value. So therefore F is equal to 1. Therefore the force that is applied is equal to 150 newtons is the value here. Let us see the option. Okay, so 1.14 is D. 1.14 is D here. Therefore it is the right answer. So please note that one. So we have to apply the force in that way here. 1.14 the value here, N is equal to M is therefore 120 newtons. So very important point I want to say is, if on this wheel a torque is applied, for example, if a torque is applied here, then we have to go for T is equal to F into R. Okay, then torque that is applied acting on the body is always equal to friction force multiplied by the radius here. So this is the wheel of the locomotive resting on the surface here, direction of the movement of the body here. To roll the wheel over this rail, what is the force that is required here? So whatever the force we are applying on this body should be equal to the frictional force. Okay, therefore it should overcome the friction force, then the body starts moving. Therefore P is equal to F here. Therefore I can say this one as P is equal to 150. Simple. And this is given for 1 mark in the 2000 question paper. That is the thing. So please note down this one. So I am having 2 more problems to do from the case of friction here. Right. Please note on that one. Right. Now see here, I'm going for the next problem. A force of 400 newtons is applied to the brake drum of 0.5 meters diameter in a brake system as shown in the figure, band brake system, where the wrapping angle is equal to 180 degrees. If the coefficient of friction between the drum and the band is equal to 0.25, band is nothing but belt or the surface, the braking torque applied in Newton into meter is equal to, I will draw the figure for you. I'm having the figure here, 1.44. This is a figure that is given for us. The center of the wheel, horizontal is nothing but vertical. Wheel here, and here we have the surface is fixed here, and at the end of the band we are applying here, I am applying a force of 400 newtons on this body. Okay, and actually the wheel is rotating in this way here. Rotating in this way here, and rather than diameters, we are applying a force of some P is equal to 400 newtons. Okay, the diameter is equal to 0.5 meters. Okay, and the wrapping angle theta is equal to 180 degrees, it is given. The coefficient of friction between the drum and the brake is equal to mu is equal to 0.25 mm. The braking torque applied will be equal to how much? Now see here the very important points we have. So actually, let us see the figure here. It's given for us. Now see, actually this is the wheel. Actually this is the wheel of an automobile that is moving in the anti-clockwise direction here. Moving in the anti-clockwise direction initially. Okay, now what I want to do is I want to stop this wheel. To stop this wheel, okay, we have the brake system here such that we have a band here. Band is nothing but something like a belt. It is made up of some material here. This belt will be surrounded over the wheel here, and one end of the belt will be fixed here, and at the other end of the belt I will be applying a force of 400 newtons here. I will be applying a force of 400. If you apply a force of 400 newtons at this end here, then this belt will be subjected to tension. Subjected to tension here. So whenever this belt is subjected to tension, this belt will apply an amount of friction force acting on this wheel, and the rotation of the wheel will be reduced here. Okay, and it should not rotate in this way. You should have to apply the force in this direction such that it should be opposite to the rotation here. We are applying the force in this direction in order to stop the wheel. Okay, that means definitely it should rotate in the opposite direction only. Okay, now what is the force that we have to apply on the body here? I am going for the thing. So braking torque. So I want to calculate the braking torque here. So before calculating the braking torque, let us calculate the tensions in the string. Tension in the string I am going for, right? Now see here. So this is called as the tight side, and this is called as the slack side. Tight side and slack side. I am having the relationship between the tight side and slack side. So T1 by T2 is equal to e power mu theta. The braking torque that is applied on the body will be always equal to, see, if you draw the free body diagram of this belt here for this pulley here. So what generally happens, nothing but tension T1, and it is nothing but tension T2 here. So T1, T2, and what about this one here? That's all. So what is the torque that we can generate by using these two tensions? Nothing but torque is always equal to net force acting on the body, nothing but T1 minus T2 multiplied by the radius of this wheel. I can see this one as the values are here. So this, see, actually this is the tight side, this is the loose side here. We are just applying the force in this direction here. So net torque acting on the body will be always equal to force multiplied by the distance. So what is the net force acting on the body? So the T1 is nothing but T2 here, right? So okay, acting in this direction, T1 minus T2 multiplied by the value of radius r. So torque multiplied by the radius r gives the value of tension T, as I told just now. Okay, so the torque that is acting on the body will be always equal to friction multiplied by the radius. But in this case, it is the case of the belt friction here. Therefore, I can say this one as T1 minus T2 into R is the value here. So to determine the value of torque, this is nothing but torque here. T1 is nothing but tension in the tight side. Sorry, I made once again. This value radius R. Therefore, I can say torque is equal to T1 minus T2 into the value of R is the value here. So if you determine these two values and if you substitute here and determine multiple values, then you can determine the torque here, right? So how we can get the value of T1 here? T1 is nothing but directly. So at this end we are applying at this side we are applying a force of 400 newtons here. That means we can say that this is the amount of tension that is developed inside the string. So more amount of force, more amount of tension. So if you pull a string, for example, whatever the amount of the force that you are with which we are pulling the string, the same amount of the force will develop inside the string as a tension. Therefore, I can say this one as T is equal to this is a torque here. So therefore, how we can determine the value of T2? So T2 is equal to, therefore I can say T1 is equal to 400 newtons. So T2 is equal to T1 divided by e power mu theta. So T1, what is the value of T1 is equal to 400 divided by e power. What is the value of mu stands for? It is equal to 0.25 multiplied by what is the value of theta here? Theta is given as 180. You do one thing, you have to multiply with this one as pi by 180 degrees because it is given in terms of degrees. So don't multiply with the degrees directly. You have to multiply with the value of theta is equal to pi. Okay, 180 degrees we have to convert. Therefore, if you multiply, if you cancel it, definitely these two values will be cancelled here. So you'll be getting the value of T2 is equal to 400 divided by e power 0.25 multiplied by how much I can say? It is nothing but pi I can say here. There is a value. So if you go for in the calculator, you can get the calculations. So after calculating all these things, the value is equal to 182.375 is the value. Is the value of tension T2 in terms of newtons. Okay, there is a value in terms of Newton here. Right, completed. Next, I want to go for the calculation of the brake torque. How we can determine the brake torque is equal to, what is the value of T1 is equal to, I am writing this one as 400 minus T2 is equal to how much? 182.337 multiplied by what is the radius I am having? Radius is equal to how much? Diameter. Therefore, I write this value as 0.5 by 2. So don't forget to divide it by 2. So if you don't multiply by 2, you will be getting some answer. That answer will be also available in the options. So you will catch that hot cake. So be careful with that. Okay. So therefore, I can say this one as torque or brake torque I want to say, because it is, we are stopping the vehicle. We are not accelerating the vehicle here. So brake torque is equal to, after substituting all the values, the value is equal to 54.4 Newton meter is the value here. Because torque is nothing but always force into distance, no? So we are getting Newton into meter only. 54.4 Newton into meter is the value. That is a problem. So this problem is given for 2 marks in the year 2012. Okay. To go over one more problem I'm having. Yeah, please note on this one. This is the final value here. 54.4 is the final value. This is the brake torque we have to apply on the body to come to the rest. Okay. So I'm going for the next problem. The last problem in case of friction. This problem is given for 2 marks in the year of 2005. 2005 it is given. Okay. So the problem is 2 books of mass 1 kg. 1 minute. Two books of mass 1 kg, each are kept on a table. Each are kept on a table one over the other. The coefficient of friction on every pair of the contact surface is 0.3. The lower book is pulled with a horizontal force F. The minimum value of force F for which slip occurs between the 2 books is. Okay. Just I will draw the diagram, then you can understand clearly. The diagram may be given to, may not be given to in the question. Okay. So I am just giving this value here. So this, the 2 number of books I am having. So let us take this the book number 1 and this is the book number 2 here. Okay. So let me write the given data for this problem 26. Okay. So 2 books of mass 1 kg. 1 kg. Let us assume that these 2 bodies are having same mass. Okay. Then therefore we can write M1 is equal to M2 is equal to 1 kg I am having. There is a mass of each book. Okay. The coefficient of friction on every pair of the contact surface mu is equal to always 0.3. It is given. The lower book is pulled with a horizontal force. So this is the lower book here. I am applying a force F. The minimum value of force F for which slip occurs between 2 books is. So what is the force F should be applied on this lower book in order to create the slipping. That means nothing but to provide the movement inside the book of 2. What is the force that is required? Okay. So for that we have to we have to draw the free body diagrams for 2 number of blocks, and one more important point is we have 2 contact surface here. So between 1 and 2 we have a contact surface here. Between 2 and floor we have contact surface here. For both the contact surface the coefficient of friction is equal to 0.3 it is given. So let me draw the free body diagram for the second block first. Second book I am taking. Okay. So this is the second book I am taking here. The second book I am taking here. So for this second book, what is the free body diagram? So it is nothing but F. Let us assume this is the contact surface. Contact surface A I am saying. This is a contact surface B I am saying. 2 contact surface I have. So therefore I can say this one as the normal reaction Na. So this is the weight of the book 2. Nothing but weight W2 I am writing here. So what is the contact friction we have? W2. So F is acting in this way. Therefore frictional force will be always acting on opposite direction. Nothing but the value FA I am saying. Okay. So next, any more things we have here? We have a contact surface, right? So I can say this one is nothing but is equal to FB. FB is acting in this way here. Okay. And this is in contact with some other surface. So we'll be getting the normal reaction that is acting on this surface in opposite direction. It's nothing but the value NB I can say, because this book is resting on the surface here. Because yes, due to this book, since the book is resting on this surface here, the weight of the book will be acting on this book. We have to count that weight of the book onto this book with in the terms of normal reactions here. So we cannot write the weight directly on the book here. You may have some inclined force acting on the body. So we have to count all the forces here. So the weight of the book will be acting on this block in the form of the normal reaction here. So nothing but Na and Nb. So this is the free body diagram for this block here. This is nothing but the value W2. Okay. Now if you draw the free body diagram, if you have the equations, let me draw the free body diagram for this block also. I am taking this is the block number 1 here. So weight of one acts in the vertically downward direction. Okay, and what about this one? Nothing but the normal reaction. So it is the normal, this is the surface B. I am writing this one as NB here. Okay, and what is the direction here? Since it is NB, okay, it is clear. So NB, so we got NB acting upward. What about frictional force here? You can see this is the contact surface with this surface, right? So since FB is coming in this direction, so for the contact you have to provide the frictional force acting in the opposite direction here. This is the way how we can represent. Okay, now write the equations of equilibrium for this body. I am writing the equation for sigma Fx is equal to 0. So minus FB plus F, okay, minus FA is equal to 0 I can write. And if I sigma Fy is equal to 0, Na minus Nb, okay, so minus W2 is equal to 0 I can say. These are the two number of equations I am having. Okay, now what about that one? I can say this one as, yeah, NB is simply equal to W1 I can say. And what about the horizontal force acting on the body? We don't have any, I think there is no need for considering the free body diagram for this block, I think so. So NB and FB, and the second thing is nothing but weight I can get, that's all. Right. Okay. Now, so if you solve the equations and if you determine the values here, then you can determine the entire thing here. So we can get the two number of equations here from the first book. What is the weight? And we have the weight that is acting here. I wrote that one. So mu n1 is the value here. N1 is equal to m into g. I can write simply, and also I can write n1 plus mg is equal to n2. I can from this equation I can write. I need the value of n2. So what is the value of f I need? Mainly I need the value of f here. See, this is the value of f. F is equal to, always I can write this one as fa plus fb is the value. Okay. Therefore here I can write this value as, yeah, mu into na plus nb I can write, because mu is constant at all the contact surfaces. Now how we can determine the value of na and nb? You can see here, this is equal to na minus nb. Nb is equal to what I can say? W1. Therefore I can say this one as na, yeah, is equal to W2 plus NB I can write here, which is equal to, so what is the value of NB here? Nothing but W2 plus W1 is equal to nothing but the value of Na I can write, right? So you got NB is equal to W1 and Na is equal to W2 plus W1. Therefore I can write this value as, which is equal to mu how much? 0.3 multiplied by, what is the value of Na? W1 or W2 is nothing but, I can write this one as m into, so W2 is nothing but I can write m into m2 into g, plus I can write this one as m1 into g. So what is the value of g is nothing but 9.81. So what is the mass of each block? Is nothing but 1 plus 1 is equal to 2 kgs I can get. So 2 into 9.81 newtons is the value of Na I can say. Now substitute the value of Na I can write. So 2 into 9.81 is our value. What is the value of NB I can get? NB is nothing but weight over W1, which is equal to 1 more step I want, right? So M1 into G I can write. So 1 into 9.81 newtons is the value. Okay. Therefore I can write this value as 1 into 9.81 is the value here. So if you substitute all these values, I can write the value of F is equal to, so 3 into mu into m into g I can say. Yes, the final value is equal to 8.8 for condition of slip occurs between the two blocks. 8.83 newtons. This is the value. This is the value of F here, right? This is the value of F. That is the value of F to move the bottom book. If we have only one book, therefore we can write simply F is equal to frictional force. But we have to count all the frictional forces here. That is the main thing. So please note down this one. It's a very important problem. And this is given for 1.26 is the problem, no? 1.26. It is given for 2 marks in the year 2005. Okay. So please note down that one. So these are the problems from previous question papers for friction. It's a very important concept. Okay. So that means actually you can take any body in the equilibrium as the first step. Any body you can take in the equilibrium. So depending upon that we have to move. This is a single block here. So actually don't worry about the sizes. Actually these two are having same mass. So I have changed the sizes to give the idea. So if you provide these two blocks in the same size, you may get confused here. So these two blocks are having same mass and same weight. Keep that point. But we can say one thing: if the cross section it may have more height, it may have more width. Then the volumes will be equal. No, what is there in that? If the volume is equal, therefore definitely the mass or weight will be equal for the corresponding book or body. So that is regarding the friction here. So next we have to go for the very important concept, which is regarding the trusses and frames. I want to go for subconditional length. I want to go for. So trusses and frames, you may get get a bit from the trusses and frames, and then after completion of the trusses and frames, we'll be entering into the concept of dynamics, kinetics and kinematics. I want to enter. Okay. So we shall continue after 2 minutes. Thank you.